Welcome to Impact Signals, Social Impact at the Scale of AI. I'm Charlie.
And I'm Sarah.
Wednesday, April 22nd, 2026, Episode 53. 3 stories from the last 72 hours. Wildfire detection collapses from 24 hours to 40 seconds. Italy deploys the first railway earthquake early warning system. And a look at what actually scales for humanitarian operations in low connectivity environments. Let's start with wildfires. A Florida startup just won one of 4 Verizon $1 million disaster resilience prizes. What did they build?
The company is Fire Neural Network, FNN for short, spun out of the University of Florida, powered by the HiPerGator supercomputer on campus. They built an AI system that reads lightning sensor data and identifies fire-starting strikes in about 40 seconds. Before FNN, that detection window was closer to 24 hours. Satellites or ground crews spotting smoke after a fire had already taken hold.
Why is the gap between those two numbers so important?
Because wildfire math compounds fast. A strike that gets suppressed in the first hour costs the federal government and state agencies a fraction of what a multi-day fire costs, both in dollars and acres burned. And more importantly, in human terms, evacuations, structures lost, lives at risk. Moving from 24 hours to 40 seconds isn't an efficiency improvement, it's a category change. It turns wildfire response from reactive to preemptive.
This is also a story about where AI infrastructure sits.
It is. HiPerGator is a university-owned supercomputer running NVIDIA hardware, so FNN trained and tested on a publicly funded research cluster with a clear technology transfer pathway out into a venture-backed company. That's the NSF to commercial deployment pipeline working the way it's supposed to. If you're a practitioner thinking about where real disaster AI is being built, the answer this week is inside university HPC centers, not inside big tech labs.
Pivoting to earthquakes, there were 2 parallel announcements worth pairing. Italy activated its railway early warning network, and the U.S. expanded offshore sensors on the Cascadia margin.
Italy first. They switched on the first operational railway earthquake early warning system in the country on Tuesday. When the sensor network detects the fast-moving P waves from a quake, it sends a stop signal to trains before the slower, more destructive S waves arrive. For high-speed rail, that's the difference between a controlled break and a derailment. The system is running on the Milan-Naples corridor first, with plans to extend.
How does it compare to what Japan and Mexico have been running?
Japan's Shinkansen network has had seismic braking since the 1990s. It's one of the reasons bullet trains have a near-zero fatality record through earthquakes. Italy is catching up, not pioneering, but they're importing a proven pattern into a different geological and economic context. That's a model other mid-seismic risk countries should watch: Turkey, Greece, Chile, Portugal. Infrastructure hardening through sensor networks is a lot cheaper than rebuilding rail after a major event.
And the U.S. side?
NOAA expanded the Cascadia Initiative offshore sensor array this week, more seafloor seismometers between Vancouver Island and Northern California. The Cascadia subduction zone is the source of the big one that scientists have been warning about for decades. Denser offshore sensing means earlier tsunami warnings for coastal communities in Oregon and Washington. You get minutes, not seconds of notice. Minutes are what get people to high ground.
NVIDIA also shipped something relevant this week, Earth 2.
Yes, and this matters because it's open. NVIDIA released the Earth 2 software stack, climate and weather simulation tools, plus a tsunami prediction module, and made the core components freely available for research and government use. That's a different posture than most AI foundation model releases. For agencies in smaller countries that can't afford bespoke simulation contracts, having open climate AI tooling that runs on standard GPUs is a real deployment equity shift.
Deployment equity is a thread through all of these stories.
It is, and it connects to our third piece. On Monday, which was World Creativity and Innovation Day, UNRW, the UN Relief Works Agency for Palestine Refugees, highlighted the digital platforms they've deployed for field operations. The systems are designed for low connectivity environments. Phones go online intermittently, bandwidth is limited, devices are shared. The platforms handle health records, education delivery, and cash assistance distribution for hundreds of thousands of people.
What's the technical approach that makes that work?
Offline-first architecture, store and forward sync, small data payloads, translation into the local languages, not just the donor languages. It's the opposite of the consumer tech design default, which assumes you're always connected, always on the latest device, always in the language the software was written in. Humanitarian tech that actually deploys has to invert all of that.
Why is this worth flagging on an AI briefing show?
Because the AI narrative is dominated by frontier models that need gigabit internet and 16 gigabyte GPUs. Most of the humanitarian work happens in the opposite environment, and the deployment equity gap between what's technically possible and what actually reaches the people who need it is arguably the hardest unsolved problem in applied AI right now. It's not a modeling problem, it's a systems, infrastructure, and design problem.
Funding corner before we close.
UNICEF and the Baxter Foundation announced a climate-resilient WASH partnership, that's water, sanitation, and hygiene, targeting 150 schools and 40 early childhood nurseries in Egypt, plus resilience projects in Colombia. Sesame Solar launched View Nano, a solar and battery microgrid product aimed specifically at disaster response staging. And the Verizon Disaster Resilience Prize we opened with distributed 4 $1 million awards this week. FNN was one, the others went to companies working on flood sensing, emergency communications, and grid hardening.
The through line?
Capital is flowing towards specific, measurable problems. Detect a fire in 40 seconds. Stop a train before the shaking arrives. Deliver cash to a family in a camp without reliable internet. Not moonshots. Specific, boring, deployable wins. That's what 2026 looks like in this space. Hype has receded. Execution is the story.
That's Impact Signals for Wednesday, April 22nd.
Links to every story, paper, and product in the show notes. If you're working on any of this, send us what you're building. We read every message.
I'm Charlie.
And I'm Sarah.